Hi, welcome to this quick video on the wave function, looking at how to convert to all forms of the addition formula, which is exactly what we're doing today. What we looked at in the previous video was writing a cos x plus b sin x in the form k cos x minus alpha. What this video is about is being able to do it in the other three as well. Okay, so we know that there's four different things coming from the addition formula. We need to be able to deal with it regardless of what form we're given. Now, because of we're still going to get a k sine alpha out, and we're still going to get a k cos alpha out. So our proofs from the last video hold. K is still a squared plus b squared all square rooted, and tan alpha can still be used to find, or alpha can still be found from the tan using k sine alpha over k cos alpha. Okay, so what we've got here is we've got 4 cos x minus 3 sine x, and we want to make that look like k sine of x plus alpha this time. Okay, now we know that this sin x plus alpha expands to sin x cos alpha plus cos x sin alpha. So when you multiply it by the k, it's k sin x cos alpha plus k cos x sin alpha. Now you need to be really careful when you're using this and writing this out. You need k's at the end of both, or else you lose marks, maybe even 2 marks later on by making a mathematical inaccuracy. Just be very careful that you're doing that. Okay, so that's what we're dealing with. Okay, and this is where we need to be very careful. It's a bit more confusing because sine is with cos and cos is with sine here. But what I'd like to do is, okay, like sine x is there and sine x is there. So that means that with this sine x is k cos alpha, and with this sine x is -3. So k cos alpha equals -3. Okay, and then same goes, cos x is here, cos x is here, which means with this cos x is k sine alpha, with this cos x is 4, so k sine alpha has to be 4. Okay, and if you just keep doing that, be very careful and you won't make any mistakes. Okay, k, same again, is just the square root of -3 squared add 4 squared, which we know means k is 5. And then tan alpha is going to be k sine alpha over k cos alpha, which means it is 4 over -3 or -4 times. Okay, we're just going to double check our cast diagram, see what it is. We know we're going to have to ignore that negative. So the sine is positive, so let's tick that. Cos is negative, which means here and here, which means we're working in the second quadrant. Okay, so we're going to do inverse tan of 4 over 3, which gives us 53.1, which means alpha is 180 minus 53.1, which is 126.9 degrees. Okay, and we'll just do a bit of our admin at the end. It's 4 cos x minus 3 sin x, so 4 cos x minus 3 sin x is equal to 5 sin x plus 126.9 degrees. Okay, so same again for the marks, one for the expansion, second one for your equivalencies, third for your k, and fourth for your alpha. Okay, now you can see there's not much difference. You just need to stay on top of it. Okay, the negatives are going to come and you need to be careful with that. But also because you get different expansions, you just need to make sure you're equivalent, making the right equivalencies. Okay, second example, we're looking at cos x minus root 3 sin x in the form k cos x plus alpha. Oops, sorry. Okay, and you'll notice as well, you'll all seen it, you're all terrified of it, between 0 and 2 pi, so our alpha needs to be in radians at the end. Okay, k cos x plus alpha is cos x cos alpha minus sin x sin alpha, which makes it k cos x cos alpha minus k sin x sin alpha. Okay, now let's look at the equivalencies again. Cos x is here, cos x is here, which means connected to this cos x is k cos alpha. Connected to this cos x is just an invisible 1, so k cos alpha is equal to 1. Okay, sine x here is connected to sine x here. Now this is a little bit tricky, remember. This is now connected to negative k sine alpha. And connected up here is negative root 3. Now because they're both negative, k sine alpha is just going to be root 3. Okay, so negative k sine alpha would be equal to negative root 3. And because they're both negative, it just means k sine alpha is equal to root 3. Okay, k again is just the square root of root 3 squared plus 1 squared, which is 4. So square root of 4 is 2. Sorry, mistake. Okay, so that's just 2. And then tan alpha is going to be k sine alpha over k cos alpha. Just make sure you get it the right way around. So k sine alpha is root 3. K cos alpha is just 1, so it's root 3 over 1. And then cast diagram, sine and cos are both positive, so sine positive there, cos positive there, so we're in the first quadrant. And alpha root 3 is just 60 degrees, which in radians is pi over 3. Okay, so cos x minus root 3 sine x really means 2 cos x plus pi over 3. That's you. Let's go back to marks very quickly. I'm sure you can guess it by now. There's your first mark, there's your second mark, there's your third mark, and there's your fourth mark. Perfect. Any issues, give me a shout. Thank you.